Gantry 1, load secured. Proceeding to Bay 4.
Roger that. 1. Path is clear.
We have a flagged imperfection at the midpoint.
Yes, the ultrasonic signature confirms a subsurface void. Rerunning the sequence now.
Technicians meticulously apply the high-temperature lubricant to the ceramic die, a critical step to prevent the titanium from seizing during the upcoming press cycle.
This hydraulic creep-forming press compresses the heated titanium, eliminating springback memory as it cools under immense pressure.
The cockpit pressure vessel structure being lowered into the main forward fuselage assembly jig. Precise alignment pins guiding the floating structure into its shock-mounted position.
Low-angle view of the landing gear trunnion installation. Massive forged titanium mounting points for the landing gear being hoisted into the wing root area.
The hexagonal honeycomb core provides rigidity without adding significant weight. The adhesive film ensures a perfect bond with the titanium skin.
Easy on the descent, coming into position now.
Clear on this side.
Ready for the first bolt.
Check the laser alignment on spar 42.
It's reading green. Lower the crane.
Apply more sealant to that corner joint there.
Confirmed. Applying now.
Controlled linear track over the wingskin surface. The corrugated wingskins being lowered onto the spar structure. Alignment pins guiding the heavy skins into position.
Reading stable at 0.42.
Confirming bond integrity looks good on channel 3. Moving to the next section.
Check the torque reading on bolt 4B.
Reading steady at 90, alignment is flush.
Static authorized position at the elevon hinge assembly. Heavy-duty titanium hinges being machined and installed at the trailing edge of the wing.
Clear on the left.
Clear on the right.
Hoist slow and steady.
This is the nacelle assembly line, where massive titanium alloy structures take shape, meticulously assembled by our technicians.
Actuator response is within tolerance.
Confirmed. The oil dampening is performing optimally.
Hold it right there.
Pin is engaged. Get the mallet.
This is the completed nacelle unit, resting on its transport dolly. Technicians are ensuring the aerodynamic line.
The rear section of the aircraft, which houses the engines and tail assembly, is being constructed.
Torque on that hard point is good. Okay, locking pin secured. Let's run the functional check.
Linear track along the thermal expansion joints. The rear fuselage design incorporating sliding joints to allow the airframe to grow by several inches at speed.
Okay, cycling it down now. Watch the clearance.
Clear. The extension mechanism looks stable.
Static authorized position verifying aft alignment. Laser trackers measuring the distance between the two engine mount center lines to ensure perfect symmetry.
No indication of seepage on the lower aft.
Noted.
Pressure remains stable across the board. Test successful.
Cleaning complete on section 4.
Inspection confirms surface integrity is within tolerance. Ready for mating.
Slow and steady, winch left 5 millimeters.
5 millimeters left, understood.
We have alignment. Lock the cradles.
Static authorized position at the wing root mate. The left delta wing being moved into position against the fuselage. The complex interface of fuel lines,
Hey, bring the jacks up slowly. Copy that. Watching the angle on the inboard side. Latch is clear. Ready to lift?
Affirmative. On my count. Hoist.
Clearance is tight on the starboard side, coming in at 0.05. Copy that, moving it slowly.
Final alignment check complete. We are within tolerance.
Yeah. Confirmed on the AG330 interface. Good to go.
The large titanium panels are lifted, restoring the smooth aerodynamic lines of the nacelle, transforming the mechanical skeleton into a sleek lifting body.
Here is the final integration check. All parameters are nominal.
Looks correct. Signed and approved.
Linear track along the flight control rods, the mechanical linkage running from the cockpit stick to the rear elevons. We see the metal push rods moving back and forth in the fuselage spine.
Heavy tanks of liquid nitrogen are being installed. These are used to pressurize the fuel tanks and prevent explosions at high heat.
Calibration sweep initiated. How are the readings on the gimbal stabilization?
Within tolerance. Proceeding with the test pattern.
Static authorized position at the brake stack, the multi-disc carbon brake assembly being slid onto the axle. These high-tech brakes are designed to operate at red-hot temperatures.
Canopy engaged and locked. Pressure check stabilizing now.
Reading confirmed. Logging the data.
A team of workers wiping down the entire titanium skin with solvents, removing manufacturing oils, fingerprints, and
Mid-shot fixed angle on the chines. The sharp edges of the aircraft receiving extra coats of radar-absorbent material. The wedge-shaped structure.
The paint needs to bake to bond correctly with the titanium.
Authorized position at the nose cone.
Close up on the surface texture. Macro shot of the iron ball paint. It is not perfectly smooth. It has a microscopic grain.